Dear, let's solve another minimization, cost minimization function, which is the most raw form, that is the primal. It is the primal. Whenever we solve any linear programming problem, we always end up with this mathematical model. What we need to do, we need to convert it into the dual form. Why? Because we have the choice and we have the option to make the models into different form. So with the same objective of the cost minimization, that is the profit maximization, so we make a profit function over here. Basically, cost minimization equals to profit maximization. Profit maximization. So you see we are maximizing the profit in the dual one. In the dual. So as we know that these are the coefficients 3, 2, 4. So coefficients will be the constraints right hand side in the dual form, and the constraints of the primal will be the coefficient of the dual form. So let's take the first constraint, that is 7, right hand side of the constraint 7, and x1 will be converted into y1 plus 4 is the second right hand side constraint. So we take 4 and with the y2 plus third is the 10, and we take the y3 plus 3, that is the fourth constraint, y4, and the fifth one is 2y5. You see it has 5 variables in this. Okay, why? Because we are maximizing it. As I already mentioned, the profit maximization is also same like a cost minimization. So you see over here in the minimization, we had a function of this 3x1 minus 2x2 plus 4x3. Over here you see zy equals to 7y1 plus 4y2 plus 10y3 plus 3y4 plus 2y5. So it is longer than this, but it is another way to make the dual form. Okay, now let's talk about the constraints. So in the constraint you see first we need to make a matrix of this whole 5 coefficients of all the constraints of the primal function. That is 3, 5, 5, 4, okay, 6, 1, 3, 7, minus 2, minus 1, and 1 minus 2 plus 5. The last one is 4, 7, minus 2. So 1, 2, 3, 4, 5, and these are 1, 2, 3, 4, 5, just to validate. Secondly, we always need to take care about it that whenever we have any primal mathematical model, we need to see whether it is in the canonical form or not. Canonical form is this in the minimization of the cost. We need to have the inequalities into greater than. So this one is correct, but this one is not. And this one is correct, so we need to change it into 7x1 minus 2x2 minus x3, that is greater than equals to 10. So this inequality is converted into this. Okay, this is a very important and you cannot overlook it. Okay, let's talk about this. We need to transpose it, and the transport, we already know that whether we can convert the row to column or column to row. So we are going with this column to row. So these are the columns we have. Okay, these are the columns we have. These are the columns we have. So over here you see. Let's transpose it. In the transpose, this is the column. We are converting it into row. 3, 6, 7, 1, 4. Okay. Next column is 5, 1, -2, -2, and 7. Next column is 4, 3, -1, 5, -2. Okay, so this is done. Now let's move ahead. Since it is a transposed one, so in the transpose matrix we take these coefficients into. Okay, let's take these transpose matrix and make them a coefficient of the constraints. So the constraints you see are first is the 3, and we use we convert x1 into y1 as it is the dual form, and plus 6 with the y2 plus 7 y3, and we don't write 1, so y4 plus y5, and inequalities we know that the greater than converted into the less than, and the right hand side of the constraint of the primal 7 will be converted into the coefficient of the cost minimization function of primal, that is 3. It is 3. So 3 is this. See, second is we take another one, that is 613, that is 5 1 -2 -2 7, 5 y1 plus 1 plus 2 plus you see 1 is the, we don't have 1, -2, right, -2 y3, -2, we write -2 y4 plus 7 y5. Inequalities, as we know that it is a maximization function, and in the dual form we write minus less than, so that is the less than, and the less than we write the coefficient of the minimization one, that is -2. So -2 would be here. Okay, next we see we have the transpose matrix 4 3 -1 plus 5 -2. So over here we write 4 is over here, y1 plus 3 y2 minus 1, we don't write 1, y3 plus 5 y4 minus 2 y5. Inequalities would be same, and the coefficient over here you see over here, that is the 4 will plus 4 will be over here. So at the end always remember to write the y1 comma y2 comma y3 comma y4 comma y5 is greater than or equals to 0. So we are done with this. I just conclude this. This was the cost minimization function. This was the cost minimization function, and the cost minimization function of primal we convert into the profit maximization function when we convert it. So this function of 3x1 minus 2x2 plus 4x3 convert into 7y1 plus 4y2 plus 10y3 plus 3y4 plus 2y5. It is longer than that, but it is converted into the minimization to maximization. Now let's talk about the constraints. Constraints were 5 over here. So what we do, first step is to make a matrix of them. So we have made a matrix of them. You see 3, 6, 7, x 1, 4 plus 5 plus 1 minus 2 and plus 7 over here, and 4, 3 minus x3, that is minus 1 plus 5 minus 2 are here. So we have made a matrix of them. And before that, remember to ensure that all the constraints of the primal are into the canonical form, and the canonical form says that in the cost minimization function, all the inequalities must be greater than and equals to. So these all were greater than or equals to, except the third constraint. Third constraint inequality was changed, and the third one equality was changed. So what happened? Whenever we change inequality, we need to change the sign of them. So we have changed minus. We have multiplied minus on both sides. When we multiply minus on both sides, it becomes what? It becomes minus 7 x1 plus 2x2 plus x3 minus 10. So this was that. So since we overlook this, so we just change the sign, but it is not like that. We have to the sign will be changed whenever you convert the inequality sign as per the mathematical rule. So minus 6, 7 x1, these are the matrix over here. They were there. Minus 7 plus 2 and plus 1. Minus 7 plus 2 plus 1. So minus 7 plus 2 plus 1. So likewise over here, minus 7 plus 2 plus 1. So we are done. So that was that what I overlooked over here was the minus sign. Minus sign was always be there whenever you convert inequalities. So it was done over here. So you see the rest of the inequality were as per the canonical rule. So when the canonical rule was followed, then we make a matrix of that. Matrix was made 3, 6, 3, 6, minus 7 plus 1, 4. The matrix was done like this. 5 plus 1 plus 2 minus 2 plus 7. Okay. The last one was 4 plus 4 plus 3 plus 4 plus 3 and plus 1 plus 5 plus 1 plus 5 minus 2 minus 2. So it was transposed. We know that transpose means column to row or row to column. So we took all the columns and converted into the row. So you see these are the rows over here. These are the rows over here. So we converted them, and when we are done with the transposition, so what happened? We made a constraints one by one. Take the matrix over here and 3 into the coefficient of the constraint 3 y1 plus, we take the sign as well, plus 6 y2 minus 7 y3 plus 1 we don't write 1 y4 plus 4 y5, and the inequalities will always be shifted from, since the maximization is the dual function, we are using the maximization instead of the minimization. So in the maximization we use the less than equals to in the dual form. So over here you see, and this right hand side of the constraint comes from the coefficient of the primal cost minimization function. 3 is over here. Next we took the 5, 1 plus 1 plus y2 plus 2 plus y3 minus 2 minus 2 y4 plus 7 y5 less than equals to minus 2. The last one plus 4 y1 plus 3 y2 plus 1 y3 plus 5 y4 minus 2 y5 less than equals to, inequality were the same, and the 4 has come from here, the minus 2 has come from here. So these were done, and remember to write like this. So we are done with this question. Thank you very much.